lesson we are going to discuss about the case study on analog Butterworth filter for ECG signal processing. Okay. Can you tell me what are the types of analog filter? Anyone?
Yes, sir. Low pass filter, high pass filter, band pass filter, and stop.
Okay. Super. What are the difference between these filter? Low pass, high pass, band pass, and band filter.
Low pass filter is only taking input is only low pass, not taking a high pass. High pass filter is only taking a high frequency and not taking a low frequency. The band pass we have implement the low pass filter using a low pass filter. We can implement a band pass.
Tell me the what are the methods converting the analog to digital filter?
Bilinear transformation and impulse variance method.
Let you start your discussion.
First of all, to design a low pass Butterworth filter, a low pass Butterworth filter is reducing a high frequency, only taking off low frequency. It will use where somebody knows and low pass filters where it is using.
In ECG signals and medical fields.
Yeah, it's correct. ECG signals are very efficient to use all others, and ECG signals not accurate signal like other signals, other waves or MRI like that. It is ECG not accurate way, and ECG signals have the first order low pass filter is using to improve the waves, the P wave and the T waves. It doesn't gradually. It is normal wave like. And it's not bootstrapping the using of low pass filter. It will boost up. Not using of low pass filter, it cannot use it to boost up the waves or anything. And the second order frequencies, band pass filters and some things. It has a frequency to 0.52 and 100 Hz. It is majorly using only for first order filter, not for second order filter. In second order filter, its frequency is up to 100 Hz. It completely based on some filters, first order and second order filters. It completely the implementations, the breadboard, using of breadboard, the filter will really not stable. We have removed filters and set up all other areas. In PCB boards, it hasn't. We have solved it in PCB board. It is stable. We cannot remove, and we have make some issues in a project or anything, or we have damage of components or filters, any others. And the ECG signals are mainly used in medical fields like in bone marrow or image and anything in bone marrow cracks and muscles, any fractures like it.
Next, applied simulated in ECG signal. First of all, simulated in ECG signal. Uses of function generator to generate a waveform in ECG signals, and many of the function generator have built in the function ECG waveform or allowed frequency custom waveform programming. Next of all, real ECG devices. Alternatively, you can use a real ECG monitoring device or data from a biomedical signal acquisition system like NMI DAQ or BIO PAC, like that model, are using wave monitoring in ECG signals to provide a live ECG signals.
Okay, then now we are going to see result and analyze. Before we are going to apply the Butterworth filter in wave signal. The ECG signal has many muscles waves.
For simulation, which tool we are using?
Sir?
For simulation,
MATLAB. Okay. Then for simulation we are using MATLAB. Then we are applying the Butterworth filter. We can reduce the noise of such like Q waves, T waves and QRS waves. After that reducing waves, the muscle distortion and etc. will reduced, and then we get clear output waveform of ECG signals. Then we can need accurate of the heartbeat and need to more diagnosizations in the medical fields.
And I am curious, why we are using Butterworth filter? Why we are not using a Chebyshev filter?
We are using Butterworth filter because the Chebyshev is have more distortion and compared to the
ripples also.
Distortion and ripples compared to the Butterworth filter.
ripple occur in both passband and stop band frequency. When we are using Chebyshev filter.
In Butterworth filter there is no ripple, so we will be getting the accurate outputs.
and the advantages are simple analog implementation and no need to analog to digital converter to digital to analog converter, and digital input need to convert it into analog input, and effective noise effective, and reduction of the in pass band. Thank you.
And the limitations are in analog components, it can drift the values based on the room temperatures, affecting filter performance and ECG signals. And its adaptability, the cutoff frequencies of the components are fixed, it cannot be adjusted without redesigning the circuits. And the non-post capability, being hardware value, these filters can be allowed for flexibles or advanced filtering signal acquisitions. And the components tolerance, and the components variation in components value based on the manufacturing tolerance and degrade the filter accuracies, and noise interference. Analog may introduce or simplify noise by amplituding the low accuracy in ECG signals.
And anybody can say, oh yeah, we are using digital to analog converter.